Given a diagram with two triangles and shown that certain angles are the same, you see that we've got two here on top and bottom that are marked the same. This is 130, so that's got to be 130. These two have two tick marks here, so they're the same. And then these two must be the same because of that third angles theorem that says if you got two that match up with two, then the third ones also must match up. Okay? So I've already marked this one as 22 degrees. Because I know that 28 and 130 plus whatever this is has to add up to 180. Well, 22 is the only thing that could do this. Okay, so there's really two equations that I could write based on this information. I could say that these two are the same, so 6x minus y must equal 28. I know that that is true. The problem with that is that it's got two variables in it, and so it's going to be very difficult for me to use that to solve for both variables. The other equation that I could write is based on these two congruent angles. 4x plus y has to equal 22, and I've written that down there. 4x plus y equals 22 has to be true, but again, I've got two variables, and so I'm not really going to be able to use that to solve for both. However, I still do need both of these equations that I know to be true. Let's see what happens if we mess around with this equation and just rearrange it so that I solve for y. So I'm going to get rid of 6x on both sides, and when I do that I'm left with a negative y equals 28 minus 6x, and if I would divide both sides by a negative 1 so that y is positive, I get y equals negative 28 plus a 6x. Now I would probably rearrange this so that I've got the positive 6x first and then the negative 28 afterwards. So this is true. Y really does equal 6x minus 28, but again, I've got two variables here. It doesn't give me a specific constant. And you might say, well, what's the point of doing that? Well, now I can use this because remember, we had this other equation, 4x plus y equals 22. These two were the same. Now I know what y is in terms of x. I know that y is 6x minus 28, so I can take this 6x minus 28 and I can plug it in for y. Let's rewrite this equation. 4x plus y, which is really 6x minus 28, equals 22. Now I've got an equation where I've only got one variable, and that's really what I need to have. 4x and 6x is 10x minus 28 equals 22. I'll add 28 to both sides. So that'll leave me with 10x over here. 10x equals 50. And therefore, when I divide both sides by 10, x must equal 5. So I found half of the problem. X is 5. Now I can go back and I could plug in x for any of these things, really. I know that it could go in here to help me solve for y. It could go in here to help me solve for y. I could plug 5 in here to help me solve for y. Any one of those true equations will allow me to plug in x as 5 to help me solve for y. I'm just going to go ahead and do the same one down here, and I'm going to rewrite it. 4x plus y we found out to be 22, and now I know that x is 5. So really 4 times 5 plus y equals 22. 4 times 5 is 20. Subtract 20 from both sides. Y has to be 2. I've now found x and I've found y.